Hello everyone, welcome back to Nunley Math. I'm your host Aaron Nunley. Thank you so much for joining us here today as we talk about multiplication properties of exponents. Multiplication properties of exponents. We are well into our exponent unit now, and we're going to look at some specific instances or examples where we might be able to use some patterns that arrive with exponents to allow us to solve some problems more quickly and easily. Before we do that though, let me just review with you very quickly some of the things that we've already talked about in our previous videos on exponents, and then we'll see how we can use these things to learn something new. So let's get rolling here. Here's what we already know. An exponent is a raised number or variable in mathematics that indicates the degree or power to which an expression called the base is raised. It indicates how many of that base are being multiplied together. So if I gave you an exponent like 2 to the third, 2 would be the base, the exponent would be the 3. And if I wanted to know what that means in expanded form, 2 to the third power says take 3 2's and multiply them together. So 2 times 2 times 2, which then in standard form means 2 times 2 is 4, times 2 again is 8. Exponent form says take 3 of this base, multiply them together, and then we get a standard form of the quantity, which is in a form that's very familiar to us. We then talked about having an exponent of 0. We said that if you use a 0 as an exponent, the result is a value of 1. So if I had something like 7 to the 0, we know that's always a 1. If you're not really comfortable with that, you can go back and watch our previous video on 0 and negative exponents. And then finally, we said that using a negative exponent is a way of saying use the reciprocal of the base. So that if I have 7 to the negative third, this negative 3 right here says use the reciprocal of 7. The reciprocal of 7 is 1/7, and then you'll notice that negative 3 turns into a positive 3. That says take 1/7 times itself again. Remember, the job of the exponent is to say use this many of the base multiplied together. And when I multiply this, the numerator is 1 times 1 times 1, and I multiply the denominator 7 times 7 times 7, I get 1 over 343. I don't know why I left that in parentheses. Those parentheses are really unnecessary. I just did. All right, let's take this information and let's see what we can do with it. I'm going to give you 3 examples of some expressions that include exponents. For example, 5 to the third times 5 to the fourth. And I'm going to look at these in a very long drawn out way. We're going to look at these in expanded form, and when we've put them into an expanded form, we're going to then simplify them completely and see if there's anything interesting in there. Notice I have 5 to the third. This says take 3 5's and multiply them together, and then take that times 5 to the fourth, or 4 5's multiplied together. If I wanted to write it out, I'd do it something like this. 5 times 5 times 5 is 5 to the third. 5 times 5 times 5 times 5 is 5 to the fourth. Okay, 3 5's multiplied together times 4 5's multiplied together. And what I'm going to do is I'm going to use the associative property of multiplication, which says if I have a long string of multiplication, even if I have it broken down into groups, as long as it's just one long string of multiplication, I can regroup this any way I want. In other words, these parentheses aren't changing the value of this expression. So I'm just going to get rid of them. Notice I still have all my 5's. The only thing I've done is instead of having these 3 grouped together and these 4 grouped together, I've just written them all out because the associative property says regrouping them doesn't do anything. Well, let's see, I have 1, 2, 3, 4, 5, 6, 7 5's. In exponent notation, or in exponent form, I can write that as 5 to the 7th. Now, this is a really, really long, drawn-out way of getting from this original expression to the simplified form. What we really want to do is to be able to get from this first step down to this last form without having to do all this expanded form stuff in the middle. Now, if you pause the video and look at this for just a second, you can probably see a rule that looks like it makes sense here. I'm not going to tell you what it is. Instead, I'm going to go on to example B and allow you to think about it for just a minute. Example B says I have 3 to the 5th times 3 to the 7th. I have 5 3's multiplied together times 7 3's multiplied together. If you saw a rule or a pattern down here in example A, I would ask you to take just a second and try and apply that rule to example B, and then maybe off on a scrap sheet of paper write down what you think this answer is going to be. I'm going to work it out the long way, and then we're going to check and see if your prediction was correct. In expanded form, 3 to the 5th is 3 times 3 times 3 times 3 times 3. And 3 to the 7th is 3 times 3 times 3 times 3 times 3 times 3 times 3. Notice I have 5 3's multiplied together, and I have 7 3's multiplied together. Just like in example A, these parentheses don't really do anything because it's just one long string of multiplication. Well, I can take that one long string of multiplication, and I can write it as 12 3's, or 3 to the 12th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did your prediction hold? Were you able to figure out ahead of time what this would be without having to do the expanded form? Remember, our goal is to get from this first form to the last form without having to do all this stuff in the middle. Hopefully, these two rules that you've witnessed, this example A and this example B, hopefully you're starting to see a pattern that will allow you to predict example C. Again, I would suggest that you pause the video, you write down what you think example C would be, and I'm going to show you what it's going to look like in expanded form, and we'll see if your shortcut worked. B squared is B times B. B to the 9th is all of these b's multiplied together. Again, the associative property says these grouping symbols, these parentheses, aren't really doing anything because this is just one long string of multiplication anyway. And if I were to count how many b's I have here multiplied together, why, there are 11 of them, which makes this b to the 11th. Now you have 3 examples that illustrate for you a shortcut way of simplifying this expression. Here's what it says. If we're multiplying numbers with like bases, it can be done quickly by adding the exponents. Notice, if I have 5 to the 3rd times 5 to the 4th, I can just look at this and say, well, I have 3 of them and 4 more of them. I've multiplied 7 5's together. If I have 5 3's and 7 more 3's, well, that's just 12 3's all multiplied together. If I have 2 b's and 9 b's, well, that's just 11 b's all multiplied together. We call this the product of powers property. It says if you have like bases and the expressions are multiplied together, all you have to do is add the exponents. Much, much faster that way. Here's what that's going to look like for us. If I have something like 3x to the 4th times 4x squared, I can keep in mind that this is all just one long string of multiplication. 3 times x to the 4th times 4 times x squared, which means since it's all one long string of multiplication, I can use the commutative property to rearrange it and put my numbers together and put my variables together. The associative property says I can group my numbers together and group my x's together. Well, 3 times 4 is really easy. That's 12. And I can use my new rule to say if I have 4 x's and I have 2 x's, well, that's going to be 4 plus 2. Just add those together and get 12 x to the 6th. Now, you probably could have done it without these 3 middle steps just by saying 3 times 4 and getting 12. X to the 4th and x squared give you x to the 6th. You really don't need these middle steps. I just wanted to show them to you in case you got confused. I can do this with no matter how many expressions I have. Notice here I have a negative 2a to the 11th multiplied by 3a to the 6th multiplied by 5a. So I have 1, 2, 3 things multiplied together. Now I'm going to do this out the long way, showing the commutative and associative properties, and then using our new our new product of powers property. But you can probably look through here and do this quickly and easily on your own. Negative 2 times 3 times 5, and then a to the 11th, a to the 6th, and a. Here again, I would just look at the numbers, then I would look at the variables. The numbers are pretty easy. Negative 2 times 3 times 5, that is negative 30. This says I have 11 A's and 6 more A's and 1 more A for a total of 18 A's. This is negative 30A to the 18th. One last try. I'm going to again suggest that you pause the video, try this on your own. I'm going to keep right on going. I'm going to rearrange this and regroup this. Again, I would probably do this mentally, meaning I wouldn't actually take the time to rewrite these out. Instead, I would say 6 times 1 times 9 and get 54. I have 4 m's and 2 more m's. That's a total of 4 plus 2, or 6 m's. And then I have one last n sitting over here by itself. There's your final solution. 6 times 1 times 9 gives me the 54. M to the 4th and m squared, our rule says add those together. That's m to the 6th. And then n to the 1st. That's not too bad, right? Here's what we're going to do then. That is the first of our 3 multiplication rules. We're going to do the other 2 rules in a very similar manner. I'm going to give you 3 examples. I'm going to allow you to see if you can predict the rule, and then we're going to talk about the rule together, and then we'll just work out a couple problems to give us some practice. 2 to the 3rd to the 3rd. Now, remember that this exponent on the outside says I have 3 of whatever's inside of these parentheses. Or in expanded form, it looks like this. 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. Well, I know that 2 to the 3rd just says I have 3 2's multiplied together. This 2 to the 3rd says I have 3 2's multiplied together. This 2 to the 3rd says I have 3 2's multiplied together. The associative property says these parentheses aren't really doing anything because this is just one long string of multiplication. And so when I look at all these 2's, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. This is 2 to the 9th. Now this is an awful lot of work. It's effective in that I can see the solution using what we currently understand, but it would be much nicer if I could go from this first step to this last step while skipping these things in the middle. Probably you have an idea as to what that would be. If you do, I would suggest that you try example E without showing all those steps. Maybe just write down what you think it is, and then I'm going to do it in expanded form, and we'll see if you were able to skip all that work and come up with a solution. This 4 on the outside says I have 4 of whatever's in the parentheses. Each 7 to the 5th says you have 5 7's. So 5 7's and 5 7's and 5 7's and 5 7's. Well, that's an awful lot of 7's, isn't it? In fact, that's so many, I really don't have room to show this last step here where I write it without all the parentheses. But just know I can do that, write this without all the parentheses, and then I would just count up how many 7's I have. There's a total of 20 of them. Did your rule hold? If so, try this third one without going through the entire expanded form process. Maybe down here in the corner, write what you think it would be. I'm going to go ahead and do it in expanded form. This is g squared times g squared times g squared because I know I have 3 of them. Well, g squared is just g times itself. And these parentheses aren't really doing anything because it's one long string of multiplication. That's the associative property. How many g's do I have? G to the 6th. Did your shortcut hold? Hopefully you've already discovered that a base with an exponent raised to another exponent can be done quickly, wow, the D is missing, can be done quickly by multiplying the exponents together. Notice up here, 3 times 3 told me I had 9 of them. 5 times 4 tells me I have 20, and 2 times 3 tells me I have 6. The power of powers property says if you have a base to an exponent and that whole thing is to another exponent, we're just going to multiply those together. So here's what that's going to look like. If I have 4 to the 7th to the 8th, rather than writing out all that expanded form, I'm just going to multiply those together and call this 4 to the 56. If I have 7 to the 11th to the 9th, rather than writing all that out in expanded form, I'm just going to multiply those together and get 7 to the 99th. This would be x to the 42. Here's one for you. M to the -3rd to the -5th. A lot of people get caught up with their negative exponent rules here, and they say, oh, I need to do the reciprocal of m, and then I need to find what this is, and I need to do... If you use this property first, the power of a power property says just multiply those together first, and you're going to end up with m to the 15th. Notice I didn't have to do any reciprocals with that because when I multiply them together, I end up with a positive. If I had done it with reciprocals, this one would have used the reciprocal of m, which is 1 over m, and then this one you would have used the reciprocal of that 1 over m, which would have switched it back. It's much easier just to get rid of it at the beginning. Here's one for you. This is b to the -8. Remember, we do not leave negative exponents in our answers. It's considered to be not finished. Instead, we want to use the reciprocal, which is 1 over b to the 8. And then we're going to distribute that 8 to both of those. This is 1 times 1 times 1 times 1 times 1 for the numerator, all the way out 8 times, and b times b times b times b times b times b. 1 times itself 8 times is 1. B times itself 8 times is b to the 8th. Again, I don't think that's terribly bad, but you may want to slow down and pause the video just a second to take a look at those. One more rule for you. If I have 2mn to the 3rd, that means I have 3 of these multiplied together. Notice this is one long string of multiplication. Times, 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 2 times n times 2 times m. This is just one long string of multiplication. Well, if it's multiplication, the commutative property says I can rearrange it any way I want. The associative property says I can stick these parentheses in and regroup it any way I want. Well, this becomes 2 times 2 times 2 is 2 to the 3rd. M times m times m is m to the 3rd. And n times n times n is n to the 3rd. 2 to the 3rd, m to the 3rd, n to the 3rd. Or a lot of teachers would prefer that you change that 2 to the 3rd into 8. Can you think of a faster way to do that without having to go through all the expanded form? Look at this. Look at this. This last answer, this 8, we would have to do either way. There should be a quick way to get from here to here. Do you see it? If you do, you might want to try it on this one. I'm going to go ahead and work this out the long way. This is 5 3xy's multiplied together. Remember, that's just all multiplication. So using the commutative and associative properties, I can rearrange and regroup this. This is 5 3's. This is 5 x's. And this is 5 y's. Again, some people might want you to take that 3 to the 5th and turn it into 243. But in order to see the pattern, you're going to need to go from here to here. Do you see it yet? Let's do one more. 4f to the 5th g squared to the 3rd. I'm going to have 3 of those multiplied together. If I use my commutative and associative properties to rearrange those, I get 4 times 4 times 4, f to the 5th, f to the 5th, f to the 5th, g squared, g squared, g squared. And then I use my associative property to regroup them. That's 4 to the third, f to the fifth times f to the fifth times f to the fifth. I'm going to use my rule from earlier. I'm going to add all those together and say I have 15 of them. 2, 2, and 2. I add those together and I get 6. Or 4 to the third could be 64. Did you see the shortcut? If an exponent appears outside the parentheses, it applies to everything in the parentheses. This is called the power of a product property. If I have an m on the outside and an a and a b on the inside, that outside number goes to both of them. That's the power of a product property. This is what that can look like in our examples. 5xy to the third, I'm just going to give the 3 to all three. And then I could write it as 5 to the third, x to the third, y to the third, or 125, x to the third, y to the third. In my class, I would prefer that students did it this way, unless this was going to be just a really unreasonably large number. You might want to pause the video and try this on your own. I'm going to go ahead and do it. I'm going to give that squared to all of them. 11 squared is 121. X cubed squared, well, this is the power of a power property from earlier. I know I need to multiply those. Y squared squared is y to the fourth. This is 11 squared, x to the sixth, y to the fourth, or most teachers are going to want that as 121, x to the sixth, y to the fourth. How about this one? Again, I would suggest pausing the video, trying it on your own. I'm going to keep going. I'm going to give that 6 to all of those. 2 to the sixth, a to the fifth to the sixth. The power of a power property says those have to be multiplied. And the b to the seventh to the sixth. The power of a power says those need to be multiplied. You get 2 to the sixth, a to the 30, b to the 42, or 64, a to the 30, b to the 42. Here's one. I actually like this because there's a 0 on the outside. You could just look at this and just say anything to the 0 power is 1. If you wanted to do it the long way, you could give the 0 to everything. 3 to the 0 is 1. M to the fourth to the 0 is 1. N squared to the 0 is 1. Multiply the ones together and you get 1. Personally, I would just go straight to the 1. I wouldn't do all this stuff in the middle. Last one. That 3 goes to all of them. Negative 4 to the third, well, that's going to be negative 4 times negative 4 times negative 4, or negative 64. This is x to the 18, y to the 9. And there you have it. Hopefully this hasn't been too overwhelming for you. Again, some of the rules by themselves seem pretty easy, but then when you start mixing and matching them, it is very easy to get them mixed up as well. So you want to make sure that you have those 3 rules committed to memory. When we talk about division properties of exponents in our next video, we're going to have the same thing. So you're going to end up with a list of about 5 or 6 different rules that are very easy when you see them independently, but they can often be mixed up. So you're going to want to make sure you spend some time making sure you have those nailed down. Hopefully this has been beneficial for you. Thank you as always for joining us. Make sure you leave us a comment in the comment section. Let us know that you're out there watching. Let us know if there's anything that you would like to see us do or anything we could do to improve. If it's been helpful to you, make sure you let us know that as well. Be sure to ring that bell to turn on your notifications so you get announcements anytime we publish new material, and also make sure you like and subscribe. As always, I wish you all the very best of luck. Good luck to you guys. Take care of yourselves. Bye-bye.